Okay, so welcome to this lesson where we are going to talk about combustion analysis. Okay, we're going to talk about combustion analysis. Okay, what it is, we are going to define it, and then we are going to see how we can use this combustion analysis, okay, to find the empirical formula and the molecular formula. Okay, so to start with, we can define combustion analysis. Okay, so what is combustion analysis? Okay, so this is simply reacting a hydrocarbon. Okay, so reacting a hydrocarbon with oxygen. Okay, so hydrocarbon plus oxygen to produce water and carbon dioxide. So carbon dioxide plus water there. Okay, so this equation that I've written here, okay, is basically what we call as combustion and what analysis. Okay, so this word combust, okay, this word combust means burn. Okay, and in chemistry, when we are talking about burning something, okay, when we are talking about burning something, just know that we mean reacting, okay, something with oxygen. Okay, so whenever we react something with oxygen, it means we are burning that thing. Okay, so we are doing what we call as a combustion analysis. Okay, and the products of combustion analysis will always be carbon dioxide and what? Water. Okay, so this hydrocarbon there, okay, that hydrocarbon there, it's just a compound that is made of carbon plus, okay, it can be carbon plus hydrogen plus oxygen. Okay, sometimes it can be carbon, hydrogen and nitrogen. Okay, but the main elements that will be found in this hydrocarbon that is being burnt in oxygen will always be what? Carbon and hydrogen, hence the name what? Hydrocarbon. Okay, so whenever you get any hydrocarbon, okay, and then you burn it in oxygen, we are saying you are going to produce what? Carbon dioxide and water. Okay, so here is the thing now. So all of the carbon, okay, all of the carbon from the hydrocarbon, once you burn it in water, okay, they all go to the what? To the carbon dioxide. Okay, all of the carbon that will be in this hydrocarbon, no matter what it is, when you burn it in oxygen, all of it, okay, will go and be part of the what? The carbon dioxide. And then all of the hydrogen, okay, all of the hydrogen from the hydrocarbon will go and become part of the what? Of the water. Okay, so what does that mean? Okay, so this means that if we find the amount of carbon in this carbon dioxide, okay, if we find the amount of carbon in that carbon dioxide, we are indirectly finding the amount of carbon that was originally in the what? The hydrocarbon. And then if we find the amount of hydrogen in this water here, okay, it means we are indirectly finding the amount of hydrogen that was present in this what? Hydrocarbon. Okay, so using that method, we can know how much of the carbon was in this hydrocarbon, and again how much of the hydrogen was in this hydrocarbon. Okay, and then if we have those masses of how much the carbon, how much the hydrogen in this is in this hydrocarbon here, we'll be able to find the what? The empirical formula. Okay, and if we know the molar mass of this hydrocarbon, we'll be able to find the what? The molecular formula. So we are going to be using this reaction combustion analysis in that way. Okay, it will help us find the amount of carbon and the amount of what? Oxygen there. Okay, so let me state again. So all the carbon in this hydrocarbon, okay, goes and be part of the what? The carbon dioxide. And then all the hydrogen in this hydrocarbon will go and be become a part of this water. Okay, so by finding the amount of carbon in carbon dioxide, we are indirectly finding the amount of carbon in the hydrocarbon. Okay, by finding the amount of hydrogen in this water, we are indirectly finding the amount of hydrogen in this hydrocarbon. Okay, I hope that is clear. Okay, so now let's give an example. Okay, let's give an example. So after I've explained that, let's give an example now. Okay, so let's say we have this unknown hydrocarbon. Okay, so let's say we have 100 grams unknown. Okay, unknown hydrocarbon that contains carbon, hydrogen, and nitrogen. Okay, and then let's say the amount of carbon, okay, in the carbon dioxide after this unknown compound goes under combustion analysis. Okay, so we can write C, and then we just write Ca, Hb, and then NC there, because we don't know the exact amount of this and it's unknown. So when we react this with oxygen like that, okay, we said we are always going to get carbon dioxide plus water. Okay, so let's say now we have that 38 grams of carbon, okay, in the carbon dioxide that is produced here, and then we also have let's say for example 54 grams of hydrogen in H2O. Okay, so what does this mean here? Okay, what does that mean there? It means after you combust this unknown hydrocarbon, okay, you get an amount of carbon dioxide and also an amount of what? Water. So in this carbon dioxide that you get, we have been told that 38 of it is what? Carbon. And then in the amount of the water that we are getting, we have been told that 54 grams is what? Hydrogen. Okay, so now how can we find the mass of this nitrogen here? So remember, this unknown compound had a mass of what? 100 grams. So if the mass of carbon is 38, the mass of hydrogen is 54, what is the amount of this nitrogen here? We're just going to say 100. Okay, we're going to say 100 is as a result of adding the mass of carbon plus the mass of hydrogen plus the mass of what? Nitrogen. So for us to find the mass of nitrogen, we're just going to say this is 100 minus the mass of carbon minus the mass of what? Hydrogen, and then this is going to be equals to the mass of nitrogen. So there. Okay, so when you subtract there, you are going to get 8 grams as your mass of what? Nitrogen. Okay, so this tells us that whatever masses of carbon and whatever masses of hydrogen we get here, make sure that when you add them with the mass of the third element in that unknown compound, make sure that they always give you what? 100 there. Okay, or whatever mass you are told was here. Okay, so this is an example. So there are now some questions where you are not given the amount of carbon in this carbon dioxide, and we are also not given the amount of hydrogen in that water. Okay, so in that case, what do we do in order to find the amount of water and the amount of carbon? I mean the amount of carbon and the amount of hydrogen. Okay, we use percentage compositions. Okay, so let me write here. We use percentage composition. Okay, so for example, we know that percentage composition, okay, is given by mass of the element you are interested in. So I'll just write mass of the element, and then you divide by the mass of the whole compound, and then you multiply by 100, right? So this is how we find the percentage composition. Okay, so let's start with carbon dioxide. Okay, so we want to find the percentage of carbon in this carbon dioxide. So what are we going to do? Okay, what are we going to do in order to find the percentage of carbon? We are going to say mass, okay, of the carbon divided by mass of the carbon dioxide, and then we multiply by what? By 100. Okay, so this is going to be equals to, so you just go on your periodic table and get the mass of carbon. Okay, so the molar mass of carbon is about 12.01. We are going to divide this by the addition of the molar mass of carbon to the molar masses of what? Oxygen. So it will be 12.0 and then plus 2 multiplied by, what's the molar mass of oxygen? We are going to get 16 there. Okay, so this is what we have, and then we multiply by 100. Okay, so just get your calculator and then we punch this value. Okay, so when I punch this value, I'm getting 27. Round it off to 3 significant figures, I'm going to get 27%. Okay, 27.3%. Okay, so this 27.3% is the percentage composition of carbon in what? Carbon dioxide. Okay, so I'm going to write here carbon in carbon dioxide. We just have what? 27.3%. Okay, what about the percentage composition for water? Okay, so for water, we are just going to use the water there. Okay, so for water, let's write water here. So for water, we are going to say mass of the hydrogen in the water, and then we are dividing this by the mass of the water itself, and then we are multiplying by 100. Okay, so we want to find the percentage composition of this hydrogen here. So we're going to say this is equals to, okay, so the percentage, the mass of hydrogen from the periodic table, I can see a 2 there, so I'm going to say 2 multiplied by the mass of hydrogen is 1.01. And then we are dividing this by 2 multiplied by 1.01, and then plus the molar mass of oxygen here is what? It's 16. Okay, and then we say multiplied by 100%. So what are we going to get? So you punch this on your calculator. Okay, 3 significant figures, I'm getting 11.2%. Okay, so it means in any amount of water that you can get, okay, any amount of water that you can get, 11.2% will be the mass of what? Hydrogen. So I'm going to say hydrogen, okay, in water is just equals to what? 11.2%. So these 2 percentage compositions that I've given you there, okay, they are going to help us in our calculations when we start calculating these things. Okay, so these things are these 2 here that we've come up with are facts. Okay, so the first fact is that in any mass of carbon dioxide that you can get, okay, it can be 10 grams, it can be 1 gram, it can be 5 grams, it can be any mass. Okay, any mass of carbon dioxide that you can think of, 27.3% of that mass will be the mass of what? Carbon. And then in any amount of water that you can get, 11.2% will be the mass of what? Hydrogen. So we'll be using these facts in our calculations. Okay, all right, so I hope you understand that. So in a question where you are not given the masses of hydrogen and the mass of carbon, and then you want to find the empirical and molecular formula, you are just given the masses of the carbon dioxide and the water involved, we can use these facts here to find the mass of what? Carbon and the mass of water. So let's say, for example, I'm given 10 grams of carbon dioxide in equation. Okay, it means I can find how much of carbon is in this what? 10 grams. So I'm just going to say 27.3 divided by 100 and then multiplied by the mass that I've been given, which is 10. So that will give me, cancel there, cancel there. So this will give me 2.73 grams. Okay, so of the 10 grams of carbon dioxide, 2.73 will be the mass of what? Carbon, and then the rest will be the mass of this oxygen there. Okay, and then it's the same thing if I'm given 10 grams of water and then I want to find the mass of hydrogen in this water. I'm just going to use this percent here. So 11.2 divided by 100 and then multiplied by 10. Okay, so 0 and 0 they go. 10 divided into this, I'm going to have 1.12. Okay, so 1.12 grams will be for what? For hydrogen in this mass of what? Water. Okay, so we're going to be using these facts in order to solve our questions there. Okay, so now let's solve some example question. Okay, so here on the board I have the first question that we are going to solve. Okay, so in this question we are finding the empirical formula and the molecular formula. Okay, but the special thing about this question is that it involves combustion analysis. Okay, so whenever you give students a question that involves combustion analysis, they tend to have difficulties in calculating. So no wonder I was explaining all that thing that I was explaining. So whatever we learned there, we are going to use it in this question. Okay, so let's read the question. So the question, they are saying a compound contains carbon and hydrogen only. Okay, on combustion analysis, the compound gives 0.488 grams of carbon dioxide and 0.150 gram of water. Okay, and then they're saying the molar mass of this compound is 52.0 grams. Okay, so now the question comes. Number one, calculate the empirical formula. Number two, calculate the molecular formula of the compound. Okay, so how do we calculate the empirical formula? Okay, we have been told that this compound contains only carbon and what? Hydrogen. Okay, so it means we have to find the mass of carbon and the mass of what? Hydrogen. So remember now what we said. Okay, remember what we said. We said 11.2% of any amount of water, okay, will be what? Hydrogen. And then on the other hand, we said 27.3%, okay, of any amount of carbon will be what? Carbon. So this one here will be water, will be hydrogen, and then this one here will be what? Carbon. Okay, so let's just find 11% of this 0.150 of water to find the mass of what? Hydrogen. So we are going to say mass of hydrogen, okay, is just equals to 11.2% multiplied by 0.150. Okay, so just punch this onto your calculator. I'm getting 0.0168 grams. Okay, so you put three significant figures, and then here to find the mass of carbon, we are going to say 27.3 over 100 multiplied by what? Multiplied by the mass of the carbon dioxide. So the mass of the carbon dioxide here is what? 0.488. Okay, so just punch that onto your calculator to see what we are going to get. Okay, so here, according to my calculator, I'm getting 0.133. So round off to three significant figures. Okay, so here is the mass of carbon, here is the mass of hydrogen. And then once we have the masses of carbon and hydrogen, we just use the same method that we are using in the previous class, okay, to find the empirical formula and the molecular formula. Okay, so what did we say? We said we always arrange it in this form. So let me clear this. Okay, we said we always arrange it in this form. We start with element there. So we are finding the empirical formula here. So element, okay, we are going to say I have carbon and hydrogen. Okay, then we say masses. So the masses that we are from finding, we are going to put them here. So we found the mass of carbon to be 0.133, and then the mass of hydrogen, okay, we found it to be 0.0168. Okay, and then from there, what is the next step? We know that the next step is to find the moles. Okay, so how do you find the moles? We divide this mass by the molar mass of the element there. Okay, so we are going to say 0.133 divided by the molar mass of carbon, which is just 12.01, and then here 0.0168 divided by the molar mass of hydrogen is what? 1.01. Okay, then from here we are going to find our moles there. So you divide this on your calculator, you also divide this on your calculator. Okay, so when I divide this here, I'm getting 0.0111. Okay, and then when I divide this, I'm getting 0.0166. Okay, so once you have your moles here, okay, you pick the one which is the lowest. Okay, so which one is the lowest here? So you pick lowest and then you divide all the moles that you have there. Okay, so we see that this one here is the smallest number among these two moles. So we are going to divide this one by itself, and then we are also going to divide this one by the smallest number of moles. Okay, so what do we get here? Okay, as our ratio. So what we are getting now is our ratio. So our ratio, when I divide this, I'm going to get 1. When I divide this, I'm getting 1.5. Okay, so this 1.5, remember, we can't round it off. I said you can only round off if you have a number that is less than x.2. Okay, a number that is less than this you can round off, or a number that is greater than let me write like this. Okay, less than this number we can round off, which like this. So less than this we can round off if you have a number that is less than this, or if you have a number here that is greater than x.8. Okay, we can round off. But if you have a number that is between, okay, is between x.2 and x.8, we can't round off. So we see that this one here, the 1.5, it's between the 0.2 and the 0.8, so it's somewhere between here, so we can't round it off. So how do we deal with such numbers? You have to look for a number that you have to multiply these ratios such that, okay, you get a whole number, or you get a number that can be 1. So here we are going to say this is just 1.5. okay, so if it's 0.5, just multiply by 2. Okay, if it's 0.3, make sure you multiply by 3. So 0.5 we multiply by 3, 0.3 we multiply by 3. So if I multiply these two and multiply this one, okay, I'm going to get what? I'm going to get 2, and then on the other part, if I multiply this guy by 2, I'm going to get what? 3. So it means these two here are my ratios for my what? Empirical. So let's write the empirical formula now here. Okay, so let's write the empirical formula. So for the carbon we have a 2 here, and then for the hydrogen we have a 3. So the empirical formula will just be carbon with a 2 and then H with a 3. So this one here is our empirical formula. Okay, so we've answered the first part there for the empirical formula. Okay, and then the second part, they're saying calculate the molecular formula of the compound. So how do you calculate the molecular formula of the compound? Okay, remember we have to find the factor to multiply this empirical formula with, and that factor is equals to, okay, the molar mass of the compound, okay, or the molar mass of the molecular formula, and then we divide by the molar mass of the empirical formula. Okay, so this molar mass of the molecular formula is always given in the question like that. Okay, or they will give you quantities that will help you for the formula. Okay, so the molecular formula there is just what? 52, then divided by the the molar mass of the molecular formula is 52, and then we are dividing by the molar mass of the empirical formula. Okay, so how do you find the molar mass of the empirical formula? You go to your empirical formula here, and then so it will be 2 multiplied by 12.01 plus 3 multiplied by 1.01. So the mass that you are going to get here will be the molar mass of the empirical formula. Okay. When I'm getting 27. Okay, I'm getting 27.05. Okay, so we
because we are from 5. And then you multiply by the factor, which is 2.